All right, guys. So after today's class, I thought you guys needed a review of manipulating some of these trig problems, okay? Some of these problems involving the triangle. So what I want to do, rather than teaching a new lesson on converting radian measures to degree measures and vice versa, degree measures to radian measures, I am just going to move ahead and go over some of the problems directly from the assignment. I took most of these questions from the assignment, guys, and I'm highlighting specific problems. And the beautiful thing about this is that now you can have a recording to go back and reference. And as always, guys, when you are working through Math Excel, you will notice the question help in the top right corner, okay? You can go into there and get some help, people, get some help. Ooh, my battery level is low, so let me go ahead and charge my device here. All right, guys, so what I'm gonna do is go over about 5 or 6 problems, and then I will go ahead and leave it there, okay? So guys, first and foremost, this one is problem number 3 from assignment number 2, okay? We are just going to be solving some basic triangles, okay? We're going to find information about these basic triangles. So this one right here has a side length of 22. By the way, this is triangle A, B, C, okay? So side BC has a length of 22 units, and then they give you this angle right here, which is 35 degrees, and your job is to find the value of C. What is the value of C? So guys, when you're presented with these right triangles and they give you some information about the right triangles, the first thing you need to do is to identify what is given to you. So you've got your angle here, 35 degrees. You are given this side right here. In relation to the angle, since it's not touching the angle, we call the 22 the opposite side. And of course, the side directly across from the right angle is the hypotenuse. So guys, you have opposite, you have hypotenuse. Which one of the trig ratios is defined as opposite of a hypotenuse? Remember the SOHCAHTOA, okay? Let me see, SOHCAHTOA. I'm writing it out for you guys, okay? So in this case, the opposite over hypotenuse would be sine. So guys, listen, if it's gonna help you, always write your mnemonic device down until you feel very comfortable with just coming up quickly with which one of the 3 trig ratios this would identify opposite hypotenuse, okay? So in this case, it's gonna be the sine. So sine of the angle, what's the angle? 35 degrees, and this would equal to the opposite side, which is 22, over the hypotenuse, which we don't know, so we call it C. Now, guys, think of this as a proportion, all right? So in order to solve this proportion, we are going to cross multiply. Here, let me change the color. Cross multiply. So when we cross multiply, guys, this is what we end up with. C times sine of 35 degrees is equal to 22. Now remember, we're trying to solve for C. So to solve for C, you divide both sides by sine of 35 degrees. And of course, you're going to grab your calculators, guys. Okay, this cancels out. And grab your calculator. Make sure your calculator is in degree mode if it's not already in degree mode. And you are going to put this into the calculator so you can figure out the value, guys. Okay, see, I'm powering up my computer. I'm Shazam my computer. My calculator, it's getting late, guys, so I'm tired. My brain is tired. So guys, my C value, in order to get it, I'm gonna take 22 divided by sine of 35 degrees. So 22 divided by sine of 35 degrees. I'm telling you, my brain is seriously getting tired, okay? And when you're dealing with a side length, guys, you round it to the nearest hundredth when you're dealing with the side length. So be careful with this. So this one is going to come out to be, and this is the C value, the hypotenuse, 38.36, guys. That's the length of the side. Unless, of course, they want you to round it to the nearest whole number. So if they want you to round it to the nearest whole number, then it would be 38. Make sure you guys are checking on the rounding, okay? These problems are very finicky how you plug in the answer, guys, okay? So that's number 3 from assignment number 2, guys. All right, the next one I am going to move on to. By the way, because this is going to be a video, guys, you can always rewatch it, slow it down so it makes more sense to you, okay? So your choice, guys. It's going to be a video, so take your time with it. Now, guys, on this one right here, they want us to find the 6 trig functions, trig ratios, okay? So they give us 2 sides. They give us this leg right here, which is 7 units long. Oh, wait a minute. That can't be 7 units long. It's shorter than the other one. Shazam. Okay, I think I'm going to redraw this triangle, guys. Let me redraw this triangle because I want to make sure it's accurate. Shazam. Okay, I'm going to try it one more time. I want this one to be longer. So obviously this is going to be 7 and this one is going to be 5. That's better. Now, guys, this is the angle that is being referenced. So listen, guys. First thing you should notice is that something's missing. What's missing? The hypotenuse is missing. Now, in relation to angle theta, which side is the 7? 7 is the adjacent side. And in relation to theta, which side is the 5? Because it's not touching theta, we call it the opposite side, okay? Now, again, go to the side, write down your SOHCAHTOA, guys, SOHCAHTOA, SOHCAHTOA, okay? Write it down. So you have the trig functions right there with you, okay? So now, guys, the first step is to go ahead and calculate the value of C, the side directly opposite the right angle because it's missing. So how are we going to do that? Given 2 sides of a right triangle, we're going to use the Pythagorean Theorem. A squared plus B squared is equal to C squared. So we are looking for C. So C squared will equal to, it doesn't matter which one is A, which one is B, guys. They're both legs. But typically, you want to make the smaller number A, the larger number B, so 7 squared. So C squared will equal to 25 plus 49. And then you, oh, Shazam. I'm ahead of myself here. Let me erase that part. Shazam. Okay, guys, let's add. Okay, so when we add here, we're going to end up with 74. Now you take the square root of both sides. Now, just for argument's sake, I must say this, guys. When you take the square root of both sides, you're supposed to get a positive, negative answer. But because you're dealing within the context of a right triangle, the length of a side cannot be negative. That is why we just focus on the positive. Furthermore, guys, you cannot, I repeat, you cannot use a decimal. You can't. Okay? So since you cannot use a decimal, you have to make sure you use that square root of 74. All right, so I'm going to erase some of this over here, guys. The hypotenuse is going to be the square root of 74. And there we go. So now that you have the length of the length of all 3 sides, you've got the opposite side to the angle, the adjacent side to the angle, and you've got the hypotenuse. Now time to go to work. Let's go ahead and list out everything, guys. Every single one of those 6 trig ratios. Start off with the easiest one. Okay, so we're using the SOHCAHTOA. Sine of theta. Remember, it's the opposite over the hypotenuse. The opposite is 5. The hypotenuse is square root of 74. Now, Shazam, we're going to have to, guys, listen to this. Rationalize the denominator. So we can't leave that radical in the denominator. So get rid of it. And to get rid of it, people, we're just going to go ahead and multiply both the numerator and denominator by radical 74. So this is the answer you want to include in my math lab. So this is the sine of the angle, guys. Now let's move on to the next one. Cosine of theta will be the adjacent side, which is 7, over the hypotenuse. And just like with the sine, you're going to have to simplify this by multiplying both the numerator and denominator by square root of 74 to rationalize that denominator. Get rid of the radical from the denominator. So this one turns out to be 7 times the square root of 74, guys. Okay, and remember, guys, I gave you the problem number. Oh, I'm sorry. I left that square root over the 74. When you multiply a radical by itself, whatever number's inside the radical just comes out. So in other words, here, let me use a different color. Radical 74 times radical 74 is the same thing as radical 74 squared. So the power cancels out the root, leaving you with 74, guys. So this is the cosine of theta. Now, the tangent, guys, super easy, super duper easy. So for the tangent, everybody, it is going to be, remember, the opposite, okay, right here, using Socatura, opposite over adjacent. The opposite side is 5. The adjacent side is 7. I think the hardest part of this problem, guys, is the tedious nature of having to figure out the length of the hypotenuse. That's number 1. Actually, there's 2 things. And number 2, having to deal with the radicals and rationalizing them from the denominator. That's the hardest part. But seriously, guys, this is not a difficult problem. So now you have the 3 basic trig ratios. So now we're going to move on to the inverses, okay? So we're going to do the cosecant, secant, and cotangent. I'm going to do the cotangent first, guys, because that one is super easy, okay? So let me use a different color here. The cotangent of theta, I forgot to put theta right there, is the inverse of tangent. So that's going to be 7 over 5. See how easy that was? Okay, so now I'm going to go to secant of theta, which is the inverse of cosine. So since cosine, the original answer, is 7 over square root of 74, I'm just going to do its inverse. So that would be the square root of 74 over 7. Notice I didn't use this one right here, guys. That would have been a mess, okay? We don't want to use that one. Okay. And then last but not least, the cosecant, guys. The cosecant is the inverse of sine. So for the cosecant, everybody, CSC, let me use a different color here because I want to identify it. Okay, I want to make sure you guys can see it. So here we go. The cosecant of theta, remember, is the inverse of sine. So you want to just reciprocate this. So you are going to end up with the square root of 74 over 5, guys. Square root of 74 over 5. And just like that, we're done, guys. Just like that. And that's it. That's it. So you got all 6 of them, everybody. All 6. All right. So now, that was number 11. I think I was attempting to do 4 or 5 problems with you guys. So let me go ahead and do this next one right here. Number 12, very similar question again. Let me use a different color. All right. So guys, this one right here, this is the right triangle. Your right angle is located right here. They give you the length of the hypotenuse. The angle is angle theta once again. They give you the side opposite angle theta. So they are giving you the hypotenuse. They are giving you the opposite, the side not touching, theta. So now you got to find the adjacent side using the Pythagorean Theorem. So we're going to go into the Pythagorean Theorem again and substitute what we have. So we get c squared is equal to, it doesn't matter which one is A or B, guys. Just know that, hold on a second, let me erase this part. I should have put the C value in there, okay? So it doesn't matter which one is C I mean, Shazam, not C. Which one is A or B? Yeah, my brain is super tired right now. Okay, so guys, I'm going to plug in the 11 for C, plug in the 2 for A, and I'm going to solve for B. So now work it out. 121 is equal to 4 plus B squared. Subtract 4 from both sides. All right, guys, so we're going to end up with 117 is equal to B squared. Now, guys, here's the complicated part of this problem. We have to simplify 117. Yeah, 117 needs to be simplified. When you're simplifying radicals, this is something that you learned back in Algebra 1, Geometry, Algebra 2. You've got to simplify the radicals, no decimals, guys. So in simplifying radical 17, there's a couple ways to do it. You can figure out what perfect square goes into 117 evenly. That would be 9 times 13 gives you 117. Okay, and so you take the square root of b squared, you get b. Take the square root of 9, which comes out to 3, and the 13 remains in there. The other thing you could do, guys, is to go ahead and factor, prime factor the 117. 117 factors to 3 times 3 times 13. And so the next step is to go ahead and figure out the pairs of factors. Every time you find a pair of factor, 1 comes out. And so since 13 is not paired, you leave it inside the root. So that's what the 117, the square root of 117 simplifies to. So essentially, guys, listen, the value for B is going to be 3 radical 13. You cannot use the square root of 117 because it needs to be simplified. Okay, so this is another one where you're going to have to, oh, shoot. I just deleted the entire thing. I didn't want to do that. All right, guys. So I'm going to erase some of the side work here for the Pythagorean Theorem. And then we'll go ahead and calculate the 6 trig ratios. And remember, you have to go ahead and simplify where possible. All right. So, guys, right here, the adjacent side to the angle is 3 square root of 13. So now we're going to find the sine of theta. Oh, SOHCAHTOA. SOHCAHTOA. All right, there we go, guys. SOHCAHTOA. Yes, use it. Okay, so sine of theta is the opposite over hypotenuse. The opposite of theta is 2. The hypotenuse is 11. Now, I am going to go straight into the cosecant. Cosecant is the inverse of sine. So it's going to be 11 over 2. Oh, this one is not as bad as the previous one, guys. Okay. So now I'm going to go to cosine. Cosine of theta is the adjacent side over the hypotenuse. The adjacent is the 3 radical 13 over the hypotenuse, which is 11. Ooh, this one's going to be a little hard. Okay. Now, guys, the secant of theta is going to be the inverse of cosine. So it's going to be 11 over 3 radical 13. You're not allowed to have radicals in the denominator. So you're going to rationalize the denominator by multiplying the square root of 13 by both the numerator and denominator. So you get 11 radical 13 over, now guys, be careful down here. Square root of 13 multiplied by itself becomes 13. So 3 times 13 is going to be 39. So the answer for this one is going to be 11 radical 13 over 39, because 3 times 13 is 39. All right. And then, guys, last but not least, ooh, Shazam, the tangent of theta, guys, is going to be the opposite, right here, opposite over adjacent, 2 over 3 radical 13. But we're going to cheat a little bit because we just simplified the secant of theta. So this one is going to simplify to 2 radical 13 over 39. Yeah, we're just going to cheat, guys. This is the same thing we just did over here. That's why I'm cheating a little bit. Why am I calling it cheating? Maybe borrowing. Why do I need to call it cheating? That sounds horrible. I'm really not cheating. I'm just using my previous work to help me get through the problem faster. Shazam. All right, guys. So now, listen, next one is the cotangent. Obviously, the cotangent is going to be the inverse of tangent. So it's going to be easy. So you're going to get the cotangent of theta is equal to the inverse of tangent. So 2 radical 13, or I mean 3 radical 13 over 2. And there you are, guys. There's your 6 trig functions. And that's number 12. It is time consuming, but it's doable, guys. And you have to start with these basics so you can feel comfortable as we move forward. All righty. So that was the third example. I said I was going to do 4. I'm going to do one more. Oh, which problem is this one? I did not write it down, guys. Okay, I think it's number 13. Don't quote me on this. This is the last one I'm going to do because I need to go to bed. It's getting late, guys. It's very late, actually. Okay, this is theta. This one, they give you the hypotenuse, which is 11. Okay, the base of the triangle, which is 5. And then you got to figure out this side right here. Okay. So in relation to the angle, we have adjacent and we have hypotenuse. What are we missing? We're missing the opposite. So let's go into the Pythagorean Theorem. C squared is equal to A squared plus B squared. Substitute. C is 11. No, it's not going to give you the same answer as the previous one, guys. You actually have to do it. So 121 is equal to 25 plus B squared. Subtract the 25. So you're left with, Shazam, 96 equals to B squared. Now, you're going to have to simplify. And 96, guys, is 16 times 6, I believe. Yeah, I think it is. Let me double check. I'm going to go into my calculator here. 96 divided by 16. Yeah, 6 times. Okay, so I'm simplifying the 96. And the square root of 16, okay, becomes 4 on the outside, and the 6 remains inside. Okay, guys? So that missing side is 4 radical 6. So now you've labeled your triangle. You have all the side lengths. So let's go to work, guys, and calculate the 6 trig ratios, okay? So, guys, here we are. And then I need to mention one other thing, and I am going to go ahead and call it a night, all right? So let's start off with the sine. Oh, I forgot to write SOHCAHTOA on the side. SOHCAHTOA. All right, there we go, guys. SOHCAHTOA. So sine of theta, opposite over hypotenuse. The opposite is 4 radical 6 over the hypotenuse, which is 11. Now, if we go over to cosecant of theta, okay, now this is where you have to do some work. It's going to be the inverse of sine, so 11 over 4 radical 6. So you'd multiply both the numerator and denominator by radical 6. So you get 11 radical 6 over, now guys, be careful, right here, this is going to give you 6 because radical 6 multiplied by itself is just 6. 4 times 6 gives you 24. And we can use that again later on, guys. Next, cosine of theta is the adjacent, 5 over the hypotenuse. So the secant, oh, I don't need that. So the secant, guys, is going to be, let me use a different color. Secant of theta will be the inverse of cosine 11 over 5. And then finally, tangent of theta is going to be the opposite, or radical 6, over the adjacent, which is 5. Okay? By the way, later on, guys, you will notice tangent is actually sine over cosine. That's just a little bit of manipulation of fractions to figure that out. But that's coming up later on. Right now, we're just going to call it opposite over adjacent. And then last but not least, guys, I am going to cotangent, and cotangent of theta is going to be equivalent to the inverse of the tangent. So it's going to be 5 over 4 radical 6. Remember, we're going to cheat a little bit. We've already done all this work over here, right there, right there. How do I mark this? Okay, right here, guys. We already did all this work. So I'm just going to go ahead and use that, okay? Because I'm going to have to multiply both the numerator and denominator by radical 6. So this will simplify to 5 radical 6 over 24. So I'm using what I already know to help me get to the problem faster. Okay, guys, so there's your 6 trig ratios. And there you go, just like that, guys. We're done. Just one thing I want to mention, and then I'll close it out. And this one thing right here, guys, I don't recall which problem this is. I think it's maybe either 14 or 15. I'm not quite sure, but you can look it up. They give you the sine of theta is equal to radical 3 over 2. And they want you to find the degree measure. What is theta? What is theta equal to? That's the question. What's the value of theta? Now, guys, whenever you have to find a degree measure, you got to do the inverse. You got to do the inverse, okay? If you're not doing the inverse, it's not going to work out. And by that, I mean the inverse of sine. So in this one right here, to find the measure of theta, we're going to do the inverse of sine of radical 3 over 2. So once again, whenever you're finding a degree measure, you're going to do the inverse, guys. Do the inverse. All right, do the inverse of the trig ratio. So in this case right here, when I plug it into my calculator, I'm going to do the inverse of sine, and then in parentheses, I'm going to do the square root of 3 divided by, okay, be careful with the parentheses too. Every calculator is different, so be careful, guys. And then close off the parentheses, and I end up with a degree measure of 60 degrees, guys. Listen, everybody. Later on, as we move on through this, there are other ways to find this, especially when we go to the unit circle. And by the time you guys get through the first quarter, you will be able to identify this just by looking at it. If you have sine of theta equals to radical 3 over 2, and the question is, what is the degree measure of that? You will be able to come up with it just like that, very quickly, guys, because by then, we would know about the unit circle. We would know the position of the angles and their degree measures and their radian measures. That's all coming up. It's just that it takes some time for us to get there, to become very fluid with this, to become comfortable with this, guys. So give yourself time. And I think what I'm going to do is postpone the next lesson, guys, because I feel like some of you are not quite getting it. So that's why I needed to go over these questions. And we don't have sufficient time to really sit there in class and go over material. So by having this video right here, hopefully it helps out to clarify some of the questions you may have had. And so I am going to post this for you guys, okay? And so you can always go back and reference it, guys, all right? So that's it for now. Until next time, bye, everybody.